is about graphing rational functions and using what we call RATTEY style. And RATTEY is an acronym for all the things that we've been doing, so here we go. Okay, so graphing a rational using RATTEY. All right, before you use RATTEY, you first must factor the numerator and the denominator, remove any common factors. Because remember, common factors tell you where the holes are located. So you take the holes out, and then you jump into RATTEY. Well, what is RATTEY? Well, RATTEY, R stands for the root. Set the numerator equals 0 and solve it. A stands for asymptotes. This is just vertical asymptotes. Remember, you set the denominator equal to 0, solve it for x, then we graph it. And then we look at the factors in the numerator and the denominator. Okay, if it's in the top, the numerator, if you have even numbered exponents in the top for those factors, like a factor is repeated in the top, that's tangency. If a factor is repeated in the top, that's what you call tangency, like an x plus 2. If it's squared, then that's tangency at that root. Remember, that's a root. If it's in the bottom, it's not tangency, it's what we call togetherness. Okay, so it's togetherness about an asymptote because that comes from the bottom of the equation. We've talked about this. E is for end behavior asymptotes. Bobbio, Botno, eats DC. Okay, one of those three is what we call the end behavior asymptotes. Remember, if it's Bobbio or eats DC, you want to see, does it cross the asymptote? And we talked about how to do that previously as well. Lastly, y is for the y-intercept. Remember, plug 0 in for all the x's and solve it for y. We've been through all these steps. RATTEY just puts it all together in one acronym, so you remember all your steps. Okay, so let's try this. Okay, here's my equation. X minus 1 over x squared minus 4. First thing I want to do is factor. Always factor if you can. Bottom is a difference of squares, so x minus 2 times x plus 2. Alright, so I have it in factored form. Let's look. Are there any holes? Do I have any factors in common? No. Okay, what are the roots? Well, you set the top equal to 0 and solve it for x. Well, that makes x equal to 1. So it's a point, 0, 1, or 1, 0, sorry. A is for asymptotes. So you set each factor in the bottom equal to 0. So x minus 2 equals 0, x plus 2 equals 0. So this one is x equals 2. This is x is negative 2. So I have two vertical asymptotes. Tangency at the roots. Okay, so I look in the numerator. Do I have any factors repeated in the numerator? No. So nothing's bouncing off the x-axis. Togetherness about the asymptotes. I look in the denominator. Do I have any factors repeated in the denominator? No. This is x minus 2. This is x plus 2. They're different. They're not the same. So there is no togetherness. End behavior. Okay, is this a Bobbio, Botno, or eats DC? Exponent power is 1 on top, it's 2 on the bottom, so this is bigger on bottom. So this is Bobbio. Remember, if it's Bobbio, yo is yo answer. Oops. So it's y equals 0. Now, I have to stop and think, does this cross my asymptote? Well, if y equals 0, I set my equation equal to 0 and solve it. Okay, if I cross multiply, x squared minus 4 times 0 is 0. So I get x minus 1 equals 0. So x is 1. So it is going to cross where the x is 1 and the y is 0. And if you remember, that's the same place as my root. Sometimes that happens. Y-intercept, remember you take every x value in the equation and put in a 0. So I have negative 1 on top. 0 minus 2 is a negative 2 times 0 plus 2, which is a positive 2. So I have a negative 1 over negative 4, which is positive 1/4. So my y-intercept is at 0, 1/4. All right, now we can graph this. I have a root at 1. I have a vertical asymptote at negative 2. And I have one at positive 2. Right? No tangency, no togetherness. End behavior is at y equals 0. And yes, it's going to go through that root, but we already knew that was going to happen. Y-intercept is at 0, 1/4. All right. So it's less than 1, but it's right there. Now remember, if you have a middle section between two asymptotes, it's either going to be a parabola or cubic? Well, how do you know? Well, if it crosses the x-axis, it's going to be a cubic. And notice, these two have to connect, so that means it's going to be cubic, and it's going to go this way. There's only one place it crosses. Now, I know enough about togetherness, we've talked about togetherness, that there is no togetherness in this graph. Once I figured out the middle, I look over here in the left section. I know it's not together, so if the curve is going towards the top, if it's not together, that means the curve in this section has to be going down. On the right section, it's not together with the middle, so if the middle is going down, then the curve over here has to go the opposite direction, so it's going up. And that's all I have to do. If you're not comfortable with that, you can always do an XY table and pick an X coordinate over here, pick an X coordinate over here, and find those Y's. But your togetherness clues from your equation will tell you where the curves are going. Let's try another one, x over x plus 2. All right, it's already factored for me. Thank you very much. Now, are there any holes? No, no common factors that will cancel. The root, if x is just x on top, it's just x equals 0. So my root is at 0, 0. Vertical asymptote, I set x plus 2 equals 0 and solve it. So x is negative 2. Tangency at the roots. Are any factors in the numerator repeated? No. Are any factors in the denominator repeated? No. And behavior. Fabio, Botno, or eats DC. Okay, look at the exponent. Exponent on top is 1. Exponent on the bottom is 1. Well, its exponents are the same, so that's an eats DC. If I divide coefficients, 1 divided by 1 is 1. So it's y equals 1. Now I need to stop and decide, does it cross? Well, work it out. X over x plus 2, set it equal to my end behavior, which is a 1. Cross multiply, I get x plus 2 equals x. But if I have an x on both sides, they cancel out, and I have a 2 equals 0, but that's not true, so we know it does not cross. Y-intercept, put in 0. So I have 0 over 0 plus 2. Well, anytime 0 is on the top, that is just 0. Alrighty, so my root and my y-intercept are the same. Alright, vertical asymptote at negative 2. Okay, and behavior is that y is 1. And I know it's not going to cross the end behavior, but I know it has to go through this intercept right here, so it's going to curve this way. Can't cross the vertical. Now over here on the left-hand side of my picture, what do I know about togetherness? I know it is not together, so if the curve is going down on the right, that means it has to go up on the left. Alrighty? Okay, let's try another one. Okay, let's factor. So it's x over x minus 2 times x minus 1. Are there any wholes, common factors to cancel? No. What's the root? Set the top equal to 0 and solve it. Well, that's just 0, 0. Vertical asymptote, set the bottom factors equal to 0. So I get x is 2, and I get x is 1. So I have 2 vertical asymptotes. Tangency, do I have any factors repeated in the numerator? No. Togetherness, do I have any factors repeated in the denominator? No. And behavior, this is Fabio, Botno, or eats DC. Exponents 1 on the top, exponents squared on the bottom. So this is Fabio. And yo is yo answer, so y equals 0. Alright, if I set my equation equal to 0, cross multiply, that's just 0, and I get x equals 0. Well, okay, so it does cross at the 0, 0 point. Y-intercept, put zeros anywhere for x, so I have 0 over 0 minus 0 plus 2, that's just 0 over 2, also known as 0. So look, the 0, 0 point is repeated everywhere. It's pretty key. Alright, my vertical asymptotes are at 2, and at 1. It's a teeny tiny space in between them. end behavior asymptote is at y equals 0. Alrighty. And I know that it crosses the end behavior right here. And my y-intercept is right here. So I kind of need to know what's going on over here. So I'm going to set up a t-table just to get an idea. If I make it x is negative 2, for instance, let's just see. That would make negative 2 on the top. Negative 2 squared is 4. Negative 2 times negative 3 is 6, plus 2. So it's negative 2 over 12, negative 1, 6. So what that tells me is that the y value is down here. Okay? But it's not tangency here. It has to go through this point. So it's going to curve up along the asymptote and go through. All right? That gives me an idea of some things. Okay? Now, I know the section here between these two asymptotes is teeny tiny, but there has to be something there. Remember, it's either a cubic crossing the x-axis or it's a parabola that never crosses. So let's think about this. Do I have any roots between 1 and 2? I don't have any roots there. That means it has to be a parabola. Now, is it in the top or the bottom? We'll look at your togetherness clue. Togetherness, it says it's not together. So if this on the left is going up next to the asymptote, down here it has to be going down. And we said it's a parabola because it doesn't cross the x-axis, okay? Now, over here on the right, again, there's no togetherness. So if in the middle section it's going, if it's in the bottom, that means on the right section it has to be on the top since they are not together. Righty? All right, now I want you to try this one on your own. We'll check it when you get to class and work some more examples. Okay? Keep working at it. Follow the RATTEY method. You've already been doing it. You just didn't even know it. Okay? Make sure you bring questions with you if you have any.